Next, let's generate the ROC curve. So to run ROC curve, we need the PROC library, which we've already run. And ROC requires probability and the actual class. The actual class is in cat.medv. Then corresponding to each row, we need a probability. So we don't have probability computed with this predict function. We only determined for each row what the predicted class is. Now we want probability, so we have to run the predict again. So prob for probability bh.vl. So we run predict again, right? Same. First you need to specify the results list, which is bh.knn.cr, and then uh, the data. Okay, that would give us the predicted class, but now we have to specify that what we want is the probability, and for that you have to add one more item, which is type equal to prob. So when we do that, then the probabilities will get computed. Okay, so if you run that, and you see here the probabilities are uh, right here. Okay, now if you look at the probabilities, and you see the column heading is 0 or 1 for cat med v equal to 0, cat med v equal to 1. And these column names are not very useful, so let's give names. So names for prob.bh.vl, right? So that's the data frame for which we want to give names of C. So first one is 0, so let's call that cat.medv underscore 0, and then the next one is cat.medv underscore 1. Okay, once you run that, then if you go back, you see this, they are named as we have specified. So once we have the probability, then we can run the ROC. ROC first item is the actual class, and then the second parameter is the probability, and so this one has two columns of probability. First column is probability for 0, and the second column is probability for 1, and we want for 1, so specify cat medv underscore 1, and if you run this, then you will get the area under the curve. So right here. Okay. Now, of course, we want to plot. So we say plot equal to true. Then we can also specify some more parameters. So we want a color equal to, say, blue. Okay, line width equal to, say, 3. Okay, let's run that. Okay, so now we have, you don't want too much of padding, so we need to, for that we need to use par pty equal to, within quotation mark, S. Okay, so now if you run this, then you get more compact. Alright, so we can change the numbers to percentage, and then it's typical to specify 1 minus specificity, so the numbers will be in ascending order instead of in descending order. So that's the legacy way. So comma, and we will say percent equal to true. True should be like that, and legacy axis equal to true. Okay, run that. Okay, so it's done. So let's do some more, and we want to print AUC, area under the curve. Print AUC equal to true, and we can specify where to print. So print dot AUC dot X. Okay, where do you want the x-axis? Okay, x-axis here, remember we reversed the numbers. Numbers internally actually goes with respect to specificity 100 to 0. So if you want somewhere around here, so you need to specify that as 40, and then print dot AUC dot Y equal to, and that's in regular scale. So you want to say around here. So 20 would probably be a good place. Okay. So we have the AUC, and if you want this curve to be smooth, then we can say smooth equal to true.